Alright guys, welcome back. Today we're going to be doing experiment number 8, which is actually determining the amount of food product, or the amount of acid in a food product. So today our lab is going to use the food product is going to be pickle juice. And really what we're actually investigating when we're looking at this lab is we're looking at an acid-base reaction. So if we're thinking about it, we have HCl, so an acid, plus NaOH, a base, is going to end up making NaCl, which is also aqueous, and it also is going to make H2O. So if we're thinking about this, we're thinking about two things with varying pHs coming together and making something that's a neutral pH. So this is going to be done using a titration. A titration is actually going to be a method to very specifically determine the amount of NaOH needed to neutralize the pickle juice completely. So this lab is actually in two different steps. So we have part A, and part A is a dilution, and part B is actually the titration. So the dilution, what we're actually looking to do is we're looking to use that M1V1 equals M2V2 equation. So we have the molarity and the volume. So we have the molarity and volume of the first solution is going to equal the molarity and volume of the second. And by actually looking at our lab, we can identify what the first molarity is. Ends up being 6 molar. And as far as the amount originally used, it's going to be the 5 milliliters. And we're going to set that equal to our M2, or what we're looking for, and we're putting in a volumetric flask that is 250 milliliters, so 250 milliliters. Then we're able to solve for this M2, which is going to actually allow us to get the molarity of the dilute solution, or the solution of NaOH that we're actually going to be using in our titration setup in the second portion. So a very important aspect of this lab. For the titration itself, I'm just going to quickly explain what we're going to be doing. It's kind of in two different things. So in this lab, we would have been using something called a burette. A burette kind of looks like a large, kind of graduated cylinder, but it has like a little spout at the end. And we'll notice, or you would notice, that we have all of these markings where we actually have the most amount, so it would be, we'll just say 100 milliliters here, and we would start with 0 at the top. The reason for this is so we can easily do our subtraction, because if we're thinking about it, anything that we're putting into this burette is going to be drained out, so it's easier to take it from 0 than to do the math the other way. So this burette is what would be filled with that NaOH solution that we created in part A. And then we would have a couple different of these, but we would have these wonderful little e-flasks that include our pickle juice, which has some sort of acid in it, so I'm just going to put HCl. It's going to have our indicator, and it's going to have water. Now, one of the questions that's asked about this is, if we increase the amount of water, does it actually matter how much we're putting in this Erlenmeyer flask? And if we're thinking about that, we're thinking about all of our H plus ions, so all of our acid. And if we're thinking about adding H2O, we'll draw 2 of them just for good measure. By adding more H2O, Maybe we'll have 3 H2Os in this area right now. It's not actually impacting the amount of H plus ions. So even though we're diluting it more, it's still going to take the same amount of NaOH solution to actually fully neutralize that solution. So it does not actually matter how much water that we put in. For this particular experiment, it just makes it a little bit easier to see if we have a little bit more volume. Now, the indicator is going to be kind of important. So the indicator is actually going to go from a clear color to a pink color when it's basic. And this is very important. So you'll notice in the actual introduction, this whole idea of this H plus, and I'll put it down at the bottom here. So we have this colorless to pink. To OH minus is going to lead to C20, H12, O4, 2 minus, and 2 H2O. So when we're actually looking at this, we're seeing that in addition to the reaction that's happening with our acid base, when there is more acid in this solution, it's going to convert from that colorless to that slight pink color. So this pink that I'm writing with would actually be very, very pink, and we would assume that it would be basic at that point. But what we're looking for is just a very light pink for those titrations to show that it is just slightly basic. So it's just past neutral, which will allow us to determine that that NaOH solution from the burette is going to be just about equal to the HCl solution that's in the Erlenmeyer flask or in that pickle juice. So that is really the basics of this particular lab. We really are looking for that equivalence point, or when the moles of the acid are equaling the moles of the base. And because we are using Na plus OH minus and H plus Cl minus, we know that they're happening at a 1-to-1 ratio. So this lab also pulls in stoichiometric ratios. So if we're thinking about our moles to mole, at the end, in the calculation section, we'll be able to use a 1 molar ratio of our HCl to a 1 molar ratio of our NaOH to actually allow us to solve equations. Just another quick tidbit. I know that I did skip over it, but molarity is equal to moles over liters of solution. So that's just something else that also is included in the lab report there. So I hope this helps clarify things a little bit. As always, if you have any questions, please feel free to ask your TAs or things like that. And I will see you guys in a little bit for the calculations video.